another example. So this is the same problems that I put in the review for the first exam, or for example, chapter 2. We have the piecewise defined function with the unknown c, as c a real number. So for x less than or equal to 3, the function is defined as x minus 1 squared. For x strictly greater than 3, the function is defined as 6 minus c times x. In part A, we're going to compute the left-hand limit, or the limit as x approaches 3 negative of the function. As x approaches 3 negative, that means x is slightly less than 3. Okay, for this case, x is slightly less than 3. If x is slightly less than 3, we're going to go with the top function, which is x minus 1 squared. And this is a polynomial function. We can just replace x with the 6 or use a direct substitution. So 6 minus 1 squared or 5 squared or 25 as the answer for part A. And for part B, find the right-hand limit. For the limit x approaches 3 positive of the function. Approaches positive means x is slightly greater than 3. If x is slightly greater than 3, we're going to use the second function, which is defined as 6 minus c times x. Okay. And another polynomial that we have for part B, we just do the direct substitution to get 6 minus c times 3, or 6 minus 3c. C is the real number. Part A done, part B done. Next, part C, we're going to compute the value c for which the two-sided limits of the limit fx, x approaches 3 exist. If the two-sided limit, so this is the two-sided limit, that means the left-sided limit, or x approaches 3 negative of f of x, must be the same as the right-sided limit of the function. Okay, from part A, we have the left-sided limit, which is 25. Part B, we got the expression for the right-sided limit, which is 6 minus 3c. And now we're going to solve for c. So subtract 6 both sides to get 19 equals negative 3 times c, or c equals negative 19 over 3. Part D, we're going to find we're going to verify whether the f of x continuous at x equals 2 or not. So look at the continuity checklist. If you recall, number 1, the target is x equals 2. So we look for the function at 2. Is it defined? When you look at the function for x equals 2, so x equals 2 in the case x less than or equal to 3, right? Because 2 is less than or equal to 3. So you just replace the x equals 2 for the first function, which is 2 minus 1 power 2, or 1. So the function at 2 is defined. Next, we're going to find the limit as x approaches 2 from the left and from the right, or the two-sided limit of the function. X approaches 2, either left side or right side is still within the first interval, which is x less than or equal to 3. Or we find the limit of x minus 1 squared as x approaches 2. It's convenient that the function is continuous, which is the polynomial function. We can do the direct substitution to get 2 minus 1 squared, or 1. So we can find the two-sided limit. We can find the function value. And the step number 3, are those the same? Yes, they are. So f at 2 equals the two-sided limit or the limit f of x as x approaches 2, which is the value 1. Check, check, check. Therefore, f of x is continuous at x equals 2.